All right, college algebra, we're looking at logarithm equations and exponential equations, section 4.5. Okay? First we want to look at this. When you have an equation and you're wanting to solve and figure out what the variable is, you do the inverse. So like here we have x minus 3 equals 9. So the inverse of this minus 3 would be plus 3. So I do this to both sides. And this side will go up 3, this side will go up 3, but they'll still be equal. But what happens, this cancels because they're inverses, and I get 12. If you have this right here, 4x equals 28, that's 4 times x. So I divide, which is the inverse of times, and those cancel. X equals 7. Same thing here. X is divided by 3, so I do the inverse, which is multiply. Multiply both sides by 3. X equals 12. When I have something like this, x squared equals 25. The inverse would be the square root. That would make it cancel out. And so that means x equals the square root of 25, which is 5. But now when you square root both sides, it could be plus or minus. So you have to add that in there. And of course, if you have the square root of x, the inverse operation would be to square both sides, which the square would make that cancel, so x would equal 8 squared, which is 64. And that's how you solve just general equations. Well, what if you have something like this? With x in the exponent, 3 to the x power equals 15. How do you solve this? Well, that's where logs come in. And this little note, anytime the variable is in the exponent, you have to do a log. Anytime your variable is in the exponent, you have to do a log to solve it. So like right here, we got 3 to the x power. The base is 3. So what I do here is I do log base 3 both sides. When I do log base 3 here, log base 3 of 3 will cancel, and so I just have my x, just like the other ones. Just like every one of these all cancel. Okay? This cancels, and we have our x here. And over here I got log base 3 of 15. And then of course I can punch that in, so I'm not going to punch all these in as I do them, but this is going to be log 15 divided by log 3. So log 15 divided by log 3. And there you go, 2.46. Okay? What about this? 7 to the x equals 31. So I'm going to do log base 7, both sides. Log base 7 of 7 cancels, and I have my x, and my answer is going to be log base 7 of 31. So I'll do log 31 divided by log 7. So log 31 divided by log 7. And I get this here in 1.76. What if I have this right here? 10 to the x power equals 105. So I got to do log base 10, which is just log. I do log both sides. Log 10 cancels. I have my x equals log 105. What if I have this right here? 1/2 to the x power. My base is 1/2. So I do log base 1/2 both sides. This will cancel here, and I have just x equals log base 1/2 of 15. Okay? And then one last one. What if I have this? E to the x power equals 9. Well, I need to do a log of base e, which is a natural log. Okay? Remember, log base e is natural log. So this, I just do the natural log both sides, which these cancel now, and I have x equals natural log of 9. And so if I punch that in, ln 9, that's 2.17, 2.197. Okay? Now, what if you have a log equation like this? Log base 2 of x equals 3. Okay? Well, since it's a log base 2, I raise that as a power of 2. So 2 to the power of log base 2x equals 2 to the power of 3. But right here, 2 to the power of log base 2 cancels. And I have just x. X equals 2 to the 3 power, which is 8. What if I have this right here? Log base 5 of x equals 1.4. All right, this is base 5. So So I do 5 to the power of this equals 5 to the power of that. These cancel. X equals 5 to the power of 1.4. Let's do that here. That's going to be 9.518. Now here's when we have sometimes log of x equals 8.4. There's no base, which means it's a 10. So it means 10 to this power equals 10 to that power. This will cancel. X equals 10 to the 8.4 power. Okay, you got to remember now you're doing a power here, so that's the exponent. What if we have this? Log base x of 18 equals 3. You see this time x is in the base of the log. So that means I raise it, x to this power equals x to the 3 power. And then these will cancel off, and 18 equals x to the 3 power. And then I can do a 1/3 power like we've done before. But the thing is, we're solving for the log. Then what if I have this? A natural log of x equals 12. All right, natural log, if you remember now, natural log is log base e. So e to this power equals e to the 12 power. And this will cancel, so I just have my x equals e to the 12 power. And that's pretty much sums up how to solve for exponents and logs. So let's look at some equations here. We're going to solve these. And number 1, what is the best first step for solving the following equation? Okay. Down here at the bottom, f. We're going to take the natural log of each side. See, we got e to the power of all this. So I'm going to do a natural log of both sides, which makes this cancel. Okay. Number 2 here. What's the best first step of solving this? Okay, so we'll do 5 to this power equals 5 to that power, which will cancel this off. And so now what we've done is we've changed it to an exponent. So we've got x squared minus 10 equals 5 to the 13 power. We've changed it to the exponential form, is what we've done. And then we can solve it from there. Okay. Number 3. What's the best first step of solving this one? All right, here we got 2 logs. We can't solve an equation if there's 2 logs. So what we need to do is we need to combine them together. The answer is D right here, right? The sum of logarithm is the logarithm of a product. In other words, since I have 2 logs here, I can combine these to 1 log, and then I would have to multiply those together. So I would do the full method, 6x squared, negative 1x plus 8x be plus 47x, and then minus 8 equals 1. Okay, so I would combine these 2 together. Since I've got a plus here, then I would multiply these 2 arguments, which is this. And then I could solve it from there, but we'll go on. That's all we're doing for this. It's D. You would write that as a logarithm of the product. Okay, now number 4. Here we go. We're gonna solve this one. 2 to the x power equals 10. 2 to the x power equals 10. X is in the exponent. So what I'm going to do is I'm going to do log base 2 of both sides. This will cancel off, and x is going to equal log base 2 of 10. And so I can just punch that in. So if I punch it in, I'm going to do log 10 divided by log 2. So punch that in here. Log 10 divided by log 2. And I get 3.3219. And you can see right there's the answer. Okay, what about number 5 here? 1/5 dx equals 7. Okay, let me get a piece of paper and I'll do this a little better here. Okay, so I got 1/5 to the x power equals 7. All right, so my x is in the exponent. Every time you have x in the exponent, you got to do a log. This is my base, so I got to do log base 1/5 on both sides. This will cancel, and I have just x. X equals log base 1/5 of 7. So I'm going to do log 7 divided by log 1/5. Okay, so log 7 divided by log 1/5. And I get, I didn't see a mistake I had there. Log 7 divided by log 1/5. Negative 1.209. And you can see it right there. Okay. Number 6. Solve this one. Okay. So we got 0.4 to the x power equals 8. All right. So that means I'm going to, x is an exponent, so I'm going to do log. Log 0.4, both sides. This cancels, so I have my x equals log 0.4 base of 8. So log 8 divided by log of 0.4. All right, so log 8 divided by log 0.4. And there you go, negative 2.26, which looks like that's what they got. 7. All right, now look at 7 here. Let me write this one down. All right, on 7, we have e to the 4x minus 3 times e to the negative x power equals 3e. Okay. Now right here we're timesing these, so like when you times things with exponents, you add your exponents up. Like right here, look at this. X to the 3rd times x to the 4th is x to the 7. You just add these up. Okay? Well, that's what I need to do here. I just need to add these up. And if I add them up, 4x plus negative x would be 3x. So there you go. Okay, so I combine them together by adding the exponents. All right, now I need to divide both sides by e here because I've got this e on both sides and I need to get them combined over here. This is e to the 1. And of course, this is a rule here. If you have exponents and you're dividing them, then you subtract them. You do 3 minus 2, which would be 1. So you have to subtract them. So this is e to the 1. So I have to subtract these, which means I'm going to have this e to the 3x minus 4. Okay, kind of messed up there. Now I can solve it. So since I have e to this power equals 3, I'm going to do natural log both sides. These cancel, so 3x minus 4 equals the natural log of 3. Okay, and then I just leave this right here. I could punch that in, but it's easier just to leave it and punch it in at the end. So from here, I'm going to add 4 to both sides to make this cancel. So it's 3x equals natural log of 3 plus 4, and then I'll divide both sides by 3. And that's my answer right there. And I could punch it in, and they may not want it punched in. Let's see what they've got here. Yeah, they've got an answer here, 1.700. So we'll punch this in, okay? All right, so let me get this over here on this side. So we'll do the natural log of 3, close it up, plus 4, enter, and then divide by 3, and there you go, 1.699, which is 1.700. So we're batting 1,000. Right here, okay, x is in the exponent again, so 1/5 to the x power equals negative 7, so I'm going to do log base 1/5. These will cancel, and my x remains, so it's log base 1/5 of negative 7. Okay. Now, I should have caught this before I started. Wasn't paying attention. There's no way anything to a power could be negative 7. So this is a empty set. B here. Now you could go ahead and get to here and punch it in. I mean, if you punch this in, log negative 7, log negative 7, and then divide by log 1/5. And you see there, it's an error, non-real answer. Anyway, let's go on. All right. All right, let me get a piece of paper for this. All right, so we got 0.03 times, and then I got 1.14 to the x power equals 3. Now here's my x right here as an exponent, but I can't do anything because I got a multiplier. So what I'm going to have to do is I'm going to have to divide both sides by 0.03 to make these cancel off. And now I have 1.14 to the x power equals, and this is going to be 100, I think. 300 divided by 3 is 100. Okay. And now, since I don't have any multipliers, now I can do log base 1.14. These will cancel, and x equals log base 1.14 of 100. Okay, so we'll do log 100 divided by log 1.14. And, well, my calculator is messed up. Log 100 divided by log 1.14. And I get this here, 35.146. All right. And there you go, got it. All right, solve this one here. So we got 5e to the 9x plus 4 power equals 6. Okay, this is kind of like the last one where we got the x and the exponent here, but I got this multiplier. So I have to divide both sides by 5. And 6 divided by 5, I can do that real quick. That's 1.2. Okay, and now I got e to this power, so now I can do a log. So I'm going to do a natural log, both sides, because that's log base e, and those cancel. So I have 9x plus 4 equals the natural log of 1.2. And just leave it like that and just go ahead and solve the equation. All right, that means I'm going to have to subtract 4 on both sides. Okay, this will go away. 9x equals, now I can't do anything with that, so I'm going to have to leave them. Natural log 1.2 minus 4. And now, I got 9 times x, I can divide both sides by 9. And there's my answer right there, and I'll just punch it in. Okay, but this is going to be natural log 1.2, close it up, and minus 4, hit enter, and then divide by 9. And negative 0.424. And there you go, we got it. Okay. Solve this exponential equation. Okay. Alright, so we got 3, and then 3 to the x minus 2 power plus 1 equals 103. So here's my x in the exponent. You see that? And I got this multiplier, but I also have this adding. So now, so just treat this like it's a variable. If I had 3x, see, look here. If I had this right here, 3x plus 1 equals 103, the first thing I would do is I would minus 1. Well, let's just pretend that's an x right there. We got 3x plus 1. I got to get rid of that 1. So minus 1 on both sides. So I got 3, and I got 3 to the x minus 2 power. That goes away, and that's 102. Okay? And now I can divide by my 3. Make this cancel off. And that's that will divide, so I'll go ahead and do it there. It's going to be 34. Okay? And now, since I've got my exponent isolated here, my x is in the exponent, I can do a log of this base 3, both sides. This will cancel, so x minus 2 equals log base 3 of 34. And then I can add 2. So there's my answer right there. So I'm going to punch that in, okay? So I'm going to do log 34. Okay, let me get, you can see it a little better. Clear this off. I'm going to do log 34, close it up, divide by log 3, and then I'm going to add 2. And there you go, 5.209. 8.210, it rounded up. See, the 8 makes the 9 go up to 10. Alright, we got a couple more of these. And maybe get the hang of them. I'll go ahead and do these if you don't think you got it. You want to fast forward, it's no big deal. I've got 2. I got 1.06 to the x power plus 1 equals 8. Okay, so sort of like the last problem we did. I'm going to have to minus 1 on both sides. That's a 7. 8 minus 1 is 7. Okay, now I got the multiplier, so I got to divide by 2, which makes this cancel. And I can divide that, that's 3.5. If it's real simple like that, I can go ahead and do it. And now here comes my log. Log base 1.06, both sides. This will cancel off, and I have just my x here. And that's going to be log 1.06 of 3.5. Alright, so as I punch this in, okay, I think it looks better on this side. I'm going to do log 3.5, close it up, divide by log 1.06, and there you go, negative 11.895, which would be negative 11.896. And, oh man, we didn't get that right. Okay, here's why. I did 0.5 right there. I didn't hit my 3 very good. So let me go back up in there. There you go, 21 point, there you go. We got it now. Okay, 13. This is the last one of the exponents. I got 4, 1.028 to the x minus 2002 equals 11. Alright, so I'm going to divide both sides by 4. This cancels off. 1.028 to the x minus 2002 equals, and this is going to be 2.75. Okay. And now I can do log of this base, both sides. These cancel, so I have x minus 2002 equals log of base 1.028 of 2.75. Okay, well I got this minus here, so I need to add 2002 to both sides. This will cancel off, x is going to equal, so I'm going to do log of this, divide by log of that, and then I'll add this. Okay, so doing that, log 2.75, close it up, divide by log 1.028, close it up, and then I'm going to add 2002. And I got 2038.63, and look at there, man, we're in good shape. Okay, now we're going to switch gears, and we're going to do logarithm equations. So like number 14 here is the first one. Okay, let's do it right here. 2 natural log of x equals 12. Okay, solve this natural log equation. Well, first thing, I can't do it with the multiplier, so I'm going to divide both sides by 2. Okay, and now I got my log isolated, which means I can raise it as an exponent. And this is log base e, so e to this power equals e to the 6th power. Now these will cancel, and x equals e to the 6. And a lot of times on these, we'll just leave them like in the exponential form, like that. There's e to the 6. We don't typically type them in, I don't know why. Here's a 15, unless it just comes out to be a quickie. As you can see here, this solution is 2. So if it comes out to be something like that, we'll go ahead and do the exponent. But let's see what we got here. All right, on this one we got log base 3 of 6x minus 9 equals 1. All right, so I have log base 3 of this, so I don't have any multipliers or adding, so I can go ahead and raise it as an exponent. My base is 3, so 3 to this power equals 3 to the 1 power. Now this cancels, so 6x minus 9 equals 3 to the 1 power, which is 3. And so this is just the Algebra 1 equation now. Add 9 to both sides. 6x equals 12, and then divide by 6. And yes, we do indeed get 2. Okay. All right, let's keep this paper here for this one. Solve this one. So I got log base 4 of x plus log base 4 of x minus 6 equals 2. All right, I got 2 logs, so I need to condense those together. We had a question about this a while ago about what would be the first thing you would do. So I'm going to combine those into 1 log, which means I need to multiply these two. And if I multiply these two, I'm going to get x squared minus 6x. Okay, and now I'm ready to raise it as power. So this is base 4, so 4 to this power equals 4 squared. And these cancel. So I have x squared minus 6x equals 4 squared, which is 16. And it looks like it's quadratic, so I'm going to have to subtract 16 on both sides to make it equal 0. Okay, and then you could do the quadratic formula here. But I think it's going to be 4. Wait a minute. It's going to be 2 1/8. 4 minus 12. I think. Well, I'm trying to do this in my head. X equals negative b plus or minus a square root b squared minus 4ac all over 2a. Remember, a is 1, so it goes here and here. My b is negative 6. C is negative 16. Alright, so I got a positive 6. I got a 2 down here, and this can be 36 plus 64 is 100, and the square root of the 100 is 10. So 6 plus 10 is 16, divided by 2 is 8. And then 6 minus 10 is negative 4, divided by 2 is negative 2. That's I wasn't getting negative 2. I didn't do my negative. That's what. So there's my 2 answers right there. Okay? Here's the thing, though. I don't believe we can have this negative 2. Let's go back and see right here. I can't do log of a negative, so negative 2 is out. The answer is just 8. And we can see it right there. 8. Okay, 17. Let's do this one. Oh my goodness. This one looks, ooh, me. It's really not that bad. All right, so I have log of 4x plus 3. Okay, plus log of 4 equals log of 15x plus 16. Okay, I need to condense these two together to 1 log, so it's going to be log, and when I condense them, I multiply these two things, so 4x times 4 would be 16x, and then 3 times 4 would be 12. Okay, I probably should pull that up a little more. So, because I have 2 logs there, I multiply these arguments. So when I multiply these, I get this. Okay. Now, one thing I know is I got log both sides, which log with no base means it's log base 10. So I can just go here, 10 to this power equals 10 to that power, and they'll cancel on both sides. So I have 16x plus 12 equals 15x plus 16, and this is just Algebra 1 again now. And so I'm going to minus 15x on both sides, which makes this go away, and we'll minus 12 on both sides, which makes that go away. I got x equals 4. Okay, and there you go, man, we got it. All right, just a few more. 18. All right, so on 18, I got natural log of 5x plus 2 minus natural log of x equals natural log of 6. Okay, well these two I need to condense them, and of course there's a minus here, which means I divide these arguments. So it's going to be natural log of 5x plus 2 divided by x. Okay, so these two I have to divide them. And now I got natural log of this equals natural log of that. So I can just do e to this power equals e to that power. And they'll cancel both sides. So basically 5x plus 2 divided by x equals just that 6 over there. Okay, and then I can multiply both sides by x to get rid of this down here and have 5x plus 2 equals 6x. And then I think I'll minus 5x. And there you go, x equals 2. And we're good, man. We got every one of them right so far. All right, now we get to a word problem here. Number 19. Suppose you overhear the following statement. I must reject any negative proposed solution when I solve an equation involving logarithms. Is this correct? Why or why not? Well, not really. It's not correct. Well, these both say they're correct. This is not correct. Here's the thing. Only propose solutions that cause an argument of a logarithm to be negative. Okay, let me explain that. Okay. Suppose I have this right here. Log base 2 of 2 minus x equals something. I don't know. I'm just going to... But suppose I get x equals negative 5. Okay, I can't just go ahead and say, well, hey, it's negative. There's no solution here. Because if I put negative 5 in there, 2 minus negative 5 would be 7, which is not negative. So I can do this. So even though this is a negative solution, it doesn't mean it's not got a solution here. You always have to plug it in and make sure it doesn't make your argument negative. And that's what this is saying right here. It's proposed solutions that cause the argument of the logarithm to be negative. Those need to be rejected. Okay? Let's go to number 20. We have dealt with this before here. Okay? We're going to look at it a little different right here with the logarithms, I think, on this. So, let me write it down here. I'll just leave it. How much money will there be in an account at the end of 9 years if $5,000 is deposited at 3% interest compounded semi-annually? All right, so how much money will there be? That's the A. There's $5,000 deposited, so that's the present value or the principal. 1 plus my rate is 0.03, and my N, it's compounded semi-annually, which means it's compounded 2 times a year. And then my T is 9 years. So there's how you set it up. So now this we can just punch it in the calculator. You know, because the variable's over here, variable equals all this. So you just carefully punch it in. All right, so let me do that here. I got 5,000. And I have 1 plus 0.03 divided by 2 to the, I'm just going to put 18 power. 2 times 9 is 18. And I get this over here, $6,536.70. And we got it. Okay. Now, here's where it may change. Okay. How much time will be needed for 31,000 to grow to $34,936.76 if deposit 3% compounded quarterly? Okay, so let's put these numbers in. So this is my P right here, and this is my A. So it's going to be this, and it's going to grow to that. So I've got 34,936.76 equals 31,000. 1 plus R, which is 0.03. It's compounded quarterly, which is 4. And I have 4 times T, which T I don't know. I want to know how many years this would do. So see how my variable's in the exponent, which means I'm going to have to do a log on this. Okay, so first thing is I got to multiply here. So my equation is kind of backwards for what we have been doing the variables over here on this right side and this, but I'm going to divide by 31,000, which makes this go away. Now, I do find that in these problems here, it's best just like when this is not going to divide. I can tell that, if I have like 7 divided by 2 a while ago, that's going to be 3.5. That's fine. But this here is going to make a long decimal, so we'll just leave it. So I'm going to leave this. But it equals, now right here, all this inside here, I can punch that in. Because I think this will divide and come out to something kind of simple. So 1 plus 0.03 divided by 4. Yeah, 1.0075. And so there we go. Okay. So I divided both sides by this, which I'm just going to leave that there. And then all these I could punch in and get this number to the 4t power. And see, my t is in the exponent, and I've got all this isolated now. So now what I'm going to do is I'm going to do a log on both sides of 1.0075, which makes this cancel off. So log 1.0075 of 34936.76 over 31,000 equals 4t. Okay, sorry about that. So I do this to cancel. So I have log 1.0075 of this equals just 4t over here now. And then I can divide by 4. When I do this cancels and t equals, I punch this in. Now when I punch this in, I got to do log of this, divide by log of that, and then I'll hit equals, and then I'll divide by 4. Okay? So we got log 34936.76 divided by 31,000, close it up, divide by log 1.0075, close it up, equals, and then divide by 4, and I get 4. You see it? 4. So here we go. Oh, actually, it said round to the nearest hundredth, which you can see here. Oops. No, I'm sorry, we got the wrong. This is the right answer right here, 4. I got looking at the wrong one. This is 4.99 for the next one. Okay. All right, so let's get on this one now. Find the interest rate to the nearest hundredth of percent that would produce $3,000. So $2,500 is left at interest compounded semi-annually for 4.5 years. Use this formula again. Okay, so 2,500 is my P, and it's going to grow to this, which is my A. So I'm going to have 3,000 equals 2,500 times 1 plus my rate, which is, that's what we're trying to find. And it's compounded semi-annually, which is 2, and this is 2 times my T, which is 4.5 years. Okay. All right, so I can divide both sides by 2,500. Okay. Hey, we'll see you guys, man. Have a good weekend. Now this time I think these right here might divide. I'm going to try them. Yeah, 1.2. I thought that would divide good. And then over here I got 1 plus r divided by 2 to the 2. That's going to be 9. 2 times 4.5 is 9. Okay. And now see here, I'm not going to do a log this time because my variable's in here. So this is the 9 power. So we've done this before now. We actually have done this problem before. This is going to be 1 over 9 power, which makes this cancel. Okay, so I have 1.2 to the 1 over 9 power equals 1 plus r divided by 2. Alright, so I'm going minus 1. So 1.2 to the 1/9 power minus 1 equals r divided by 2. Okay, And then I'm going to multiply both sides by 2. Make this cancel, so R equals all this right here, and just type it straight in there in the calculator like it looks. Okay, so as I do this one here, I'm going to have the 2 parentheses 1.2 to the 1/9 power, and then minus 1, and then my parentheses, and I get 0.409. All right, which is comes over here 4.09, which is 4.1. This is around to the nearest 10, 4.1%. No, I think it said keep it nearest 100. I'm sorry, so it was 4.09. So 4.09. I thought it said 10. It was 100. Okay. 23 here. It says watch video, but you don't have to do that. This is not too bad. You got 5 natural log of x equals 35. So I'm going to divide by 5 first to make these cancel. So natural log of x equals 7. And so the natural log of x equals 7. This is log base e. So e to this power equals e to that power. And these cancel. It's just e to 7. E to 7. Okay. Yeah, we just got 3 more, I think. Uh-oh. Looking for a piece of paper here, might need. Alright, so here we got another one. Solve this equation right here. So we've got log of not base x plus log of x minus 16 equals log 80. I actually did one kind of like this just a minute ago. These two go together, and I would multiply my arguments, which gives me this. I'm going to have x squared minus 16x. Okay. And now, since it's log with no base, it's base 10, so 10 to this power equals 10 to that power, and these cancel off. So I'm going to have x squared minus 16x equals 80. And then I'll just minus 80 on both sides, and I have to do the quadratic formula. It's going to equal 0. See, when I move my 80 over here, it's going to equal 0, and I'm going to have to do the quadratic formula with this. So x equals negative b plus or minus a squared, b squared minus 4ac, all over 2a. A is a 1, so that goes in these two spots. My b is a negative 16. That goes here and here, and then negative 80 goes there. Okay. That's going to be a positive 16. The 2 down here. And this is going to be, I'm going to do this one on the calculator here. Negative 16 squared minus 4 times 1 times negative 80. And I get 576, do the square root of that answer, which is 24. Okay, oh. So 16 plus 24 is 40. 40 divided by 2 is 20. 16 minus 24 is negative 8. Negative 8 divided by 2 is negative 4. Now I got a negative here, and so like we talked about earlier, we got to check and see if this makes, we have a, yep, right there, log of x. If I put negative 4 in there, I can't do log negative 4, so negative 4 is out. So my answer should just be 20, and you see it right there, 20. Okay, 2 more and we're done. On 25 here, express the solution in exact form. Alright, so I've got natural log of 16x minus 3 equals natural log of 9. Natural log, if you remember, is log base e, so e to this power equals e to that power, which makes these cancel. So I have 16x minus 3 equals 9. So good deal. I'll just add 3 to both sides. 16x equals 12. And then divide by 16. And that's going to be 3/4. So it looks like yeah, right there. And then the last one right here. On this one, suppose this equation right here models salinity of ocean water to depths of 1,000 meters at a certain latitude. In the model, x is the depth in meters and f of x is in grams of salt per kilogram of seawater. So this is my salt right here, and then x in here is the depth. Approximate the salinity to the nearest hundredth when the depth is 364. So I'm going to put that in for x. So basically I'm just typing this in. So I'm going to type in this right here, and for x I'm going to put 364 in. So 28.8 plus 1.3 log, and I'm putting 364 for x plus 1, and I get 32.13, which is D right there. You see that's the answer. Okay, so I think that's all of them. So that's solving equations, logarithms, and exponentials, section 4.5. If you need help, give me a holler. Have a good rest of the day.